Hello everyone, welcome back to my YouTube channel Code Tracks. So today we are going to be working on statistical operation on Numpy array, and we are going to be using some basic statistic techniques that are called descriptive statistic to work with our Numpy array. So let's start by importing our modules. So we are going to import Numpy as NP, and we are going to as NP. I'm also going to import one other module, that's statistic. So import statistic as st. So let's run this. Okay, now we have successfully import the module now. So let's work with an array. Let's say we have a one-dimensional array here. Okay, let's just have 1D array first. So let's work with one-dimensional array. So let's say we have an array here. And just have 10, 12. So let's say we have this array here, and we want to have some we want to get some statistic information about this array now. What can we do now? Let's say we want to have the largest element in this array. We could just say print now. Let's just have print, and we could just have something like let's have largest element is equals to, and now you can just say a.max. By calling the function max, now it's going to print out the largest element in the array for us. And now we can say the largest element is equals to what? 30. And if you look at the array, that's the largest element we have. So let's continue now. Let's say we want to print out the smallest element. So we could just copy this. So now I want to say the smallest element now. And this will now be a.min and not max now. Now we see that the smallest element is 10. And that's what we have here right here. So now let's say we want to print the sum of all the elements we have here. Sum of elements. So we could just do a.sum, and we see we have 186. And this is just the addition of all the elements we have in here. And we could also find the mean. And the mean is just like the average, right? So we could just say mean of the elements, so let's just have mean of the elements. Let's here. I could say, and this we have to use the NP function, that's the array function. That's the array function mean, and we pass in the array we want to find the mean right here. So if we print this now, you can now see that this is the mean of this array, and we could just similarly find the median of this array. So just say median of the elements. So and here we could just have median instead. Just have median instead, and we could run this and see. So now let's talk about the mode. We could try looking for the mode. Okay, Numpy has no attribute mode, and that's why we import this statistic in first place. So instead of using the Numpy now, because Numpy actually have no attribute like mode, we could just use let me save it as mode. We use st instead. Now we are calling on the statistic module to perform that operation for us. And now we are saying that the mode is 10. That's because 10 is the most common element here. 10 appeared twice. Sorry. Yes, 10 appeared twice. So next thing we could do now is look for the standard deviation of the element. And you know that in element we could have standard deviation. Let's just say we have standard, let's have 5 elements. So now this will just be np dot, not, yeah, we don't need to use np. You can just use a dot std to do this. So once we use a.std, it's going to give us the standard deviation of the element, and we could apply something similar to this to find the variance of the element. So we can just have like this. We have the variance of the element, and this will now be variance. That's VL, just VL. You will see the variance of the element. So these are just some basic statistic operation with Numpy. So let's implement this to a 2D array now, and let's see how it works today. So I would like this to be a markdown. So okay, just call it P instead. So like to have np dot array here. So we have 1, 2, 3. So we have 1, 2, 3. And we have 4, 5, 6. Then we have 7, 8, 9. So if you have it like this, okay, let's print B out and see. Now this is our array. So we could just apply the same operation we have here. So let's copy this, not just element, and let's paste it here and just change this to B. So now we are seeing that we are returning 9 as the largest element there. And let's see the smallest element, and we could just apply that here. So we can see that, sorry, this should be changed to B. You can see that the smallest element in the array here is 1, and that's what we are returning here. So we have the sum of the elements too. Could do that and just copy all these. So we are going for the sum of the element next. So sum of the elements now, could just copy that here and paste that here. We have B. So now we have the sum of the element now to be 45, and that's very correct if you should use your calculator. So next thing we do now is, after the sum of the elements, you are finding the mean. So we should look for the mean now. So that yes, the mean is 5. So we have 9 elements, and the sum of the elements is 45. So 45 divided by 9 now is giving us 5. We can see that that is correct. So and the next thing I will look for is the median. So we can run this and consider the median now is 14. Consider the median now is 5. And if you check here, we have 4 elements to this side, 4 elements to this side, 5 is at the middle. So 5 is the median. So let's check the mode. Always forgetting to change this to this. Okay, so I believe this mode does not work for array like this. Let me try changing this to 2, 3. Okay, so I think mode does not work for 2D arrays. So let's take this back to 9. So next thing I will do after mode is, let's see if you can get it standard deviation. So yes, we have the standard deviation already, and we can also have the variance of a 2-dimensional array. So the variance, so we can get the variance. So now we see now we are having the variance here. So the next thing we are just going to do now is having, so there is a third parameter we could add to some of this operation when we are working with 2-dimensional arrays, and that's just like specifying the axis in some of the applications. So we can just specify the axis. That's either to give us for each column, yes, for each column now. So we could just like, okay, now let's just say let's start with largest number here. So we have B here, and the largest number here now, we could just say axis equals to 0. So now we are getting the max number for each column. So let me have B printed out here. So now we can see that in this first column, 7 is the biggest, is the largest number, so we have 7 here. This second column, 8 is the largest, we have 8 here. And in this third column, 9 is the largest, we have 9 here. So we could try just doing the same thing here. P, and let's have the axis set to 1. So now when the axis is set to 1, we are getting the largest number in each row itself. So now we are having 3, 6, 9 as the largest number in each row. So we could work the same way like this with the smallest number too. So let's say we have the smallest number here. We have B, mean, and we have the axis to be set to 0. So now the smallest number here is 1, 2, 3, and that's why we are getting it. Smallest number in this column, in this first column, is 1. In this second column is 2. In this third column is 3. So okay, let's have another array here called C. So we can just have some numbers that they are not in a particular order. So let's have 1, 5, 7, 89, 43, 58. So let's have this array here. Let's have this array here, and okay, we could just print C out. Okay, we have this array here now, so we could just apply the same thing here. Let's have the largest. Okay, let's say we have the largest now. Let's just do C dot max, and we have the axis to be set to 0. So now you can see that now in each column we're bringing out the largest number there, and you see in this first column it is 9 is the largest, but in the second column we have 67 as the largest, and in the third column we have 67 too as the largest, and that's why they are separated like that. So this will also work for the smallest number. So let's have 8 points. Smallest number, let's have C, and let's have it by the row this time around. Now we're having the smallest number in this row to be 1, and in this row to be 43, and in this row to be 6. So that's how it is. So now let's also work with some other operations. Let's have like sum of the elements now. So if we should have sum of the elements here, sum of the elements, so we have it here now. We could have B, and let's have the axis to be set to 0, and let's have that same sum of elements. So let's have C, and let's have the axis to be set to, let's have B here, C here, and let's have the axis here to be set to 1. So now we are getting 12, 15, 18. And what is happening here? If you print out both B and C here, you see that when the axis is set to 0, that's 0, right? If you should add this together, you are getting 12. 1 plus 4 plus 7 is 12, and that's why I'm having 12 here. And 2 plus 5 plus 8 is 15. That's why we're having it here. And here now we're adding each column together, and we are giving it to us as an array. But right here we are adding each row together. 1 plus 5 plus 7, 13. 83 plus 43 plus 67, 199. Then 23 plus 67 plus 6, that's 96. So we're adding each column together, each row together, right here, when we are setting the axis to 1. to give us this. So we could also have the mean. So let's check out how the mean will be. We could also have the mean here, and I just say mean of element b here. And right here now we just have another parameter here, and we have the axis. I'll set the axis to 0, and let's make this b, and I'd like to just have the same thing here, c, and let's make this 6. So I'd like to set this axis to 1. So now we can see that now we have the mean of each column here, the mean of each column here, and the mean of each row for this side. And that's how it works, and that's how we have it here. Just the mean, the column, and the row. So we can also work like that with the median. So you can work like that with the median, and for the median I just have for b. So, and I'll set the axis to, let's have the axis to be 0. Let's see. So now this is the median now, and you can see that for this view it's just returning all the elements here. That's because that's how it's meant to be. We have 3 elements in each column, and it's just giving us all the elements. So now if you change it to row, you see that we are getting all the elements here. That's 258. So let's try it out and see. Yes, we're getting 258 because that's the median. So we can also have it, we can also like have it for standard deviation and variance. So now we have b. Now we could just set as this here, and now it's giving us standard deviation for each column, but when we change this to 1, it will give us standard deviation for each row. And for the last but not the least, we have it for the variance. We have it for the variance, and we could have this as b, and this axis. This axis can be set to 0. And now you see that we're having the variance for each column here, and now for each row. So that will be all for today on statistical operation on Numpy array, and with this we've come to the end of this mini series on Numpy tutorial. So thank you very much for staying so far with us. If you've not subscribed to my YouTube channel, be sure to subscribe to it, and if you like what you've watched, make sure you like this video. So see you next time when I'll be posting another tutorials on Python. It could be TK Inter, King, or any other Python tutorial. Thank you very much. See you next time.